Hi everybody, Mrs. Danielson here, and today we're going to talk about the law of cosines. The law of cosines is another way to solve for a triangle that is not a right triangle, but you're going to use this one in cases where the law of sines just does not work, and it's a little bit trickier to use than the law of sines, but it's nice to have in certain cases. So let's take a look at when you will use the law of cosines versus the law of sines. All right, here we have a triangle. It is a non-right triangle, an oblique triangle, not right. So another interesting situation, right? Who knew you could use trig and triangles that were not right triangles until now? There's three different versions of the law of cosines, just depends on what you're solving for, which one you're going to use. The times when you're going to use the law of cosines instead of the law of sines is going to be if you have a non-right triangle and you're only given sides. So you're given three sides and no angles, then you're going to use the law of cosines. And another situation is going to be if you're given two sides and one angle, but the angle you're given is in between the two sides. So it's right here. If that happens, then you're not given an angle side pair. You need an angle side pair to use the law of sines. So in this case, you have a side angle side, right? The included angle. So law of sines isn't going to work. So in that case, you're going to use the law of cosines, all right? So these are the two situations you're going to use the law of cosines for instead of the law of sines. Generally speaking, if you can use the law of sines, you're going to use the law of sines. It's an easier equation to use. So this is kind of your backup plan, the law of cosines. It's not terrible to use, but just not as easy as the law of sines. So this is the backup. You're really only going to use it in those two situations. If you're only given all sides, and if you're given two sides and an angle, but the angle is the included angle between the two sides. All right, so let's go ahead and talk about an example. Let's do one that is all three sides. All right, so I'm going to give you a triangle where you're only given sides, no angles, and show you how you will use the law of cosines to help you solve it. All right, so we have triangle A, B, and C. There we go. And let's say the side lengths are 8, 5, and 12. So this is definitely not drawn to scale. That's okay. We're used to that, right? And so what I need to do is I need to solve for all three angles of that triangle. No angles given. So that means I can't use the law of sines. I'm going to have to use the law of cosines. And I need to solve for all three angles. So that means I could use any of the three forms of the law of cosines because I need to solve for A, B, and C, all three angles. But let's go ahead and say I'm going to solve for angle A first. So I'm going to solve for angle A first. I'm going to use that first version of the law of cosines. I'm going to solve for angle A first. All right. So I know A, B, and C, all three sides. So I'm just going to plug those into that form of the law of cosines. Angle A is 5. Side A is 5. Side B is 8. And side C is 12. So we're just going to plug those things in here for A, B, and C. Cosine A, and we're solving for angle A. Okay, so we're just going to chug through some math here. Right, we're just going to simplify this. 12 squared is 144. 2 times 12 times 8, 192 cosine. Okay, 64 and 144 is 208 minus 192 cosine. Okay, now we need to move that 208 to the other side, subtract it. 183 is 192 cosine A. So now when we subtract that, divide by that negative 192, the negative sign goes away, which is perfect. So we end up with a 0.953125, about that. Is cosine of angle A. Now you use the inverse cosine function on your calculator to get that angle A is about 17.6 degrees. All right, we did it. We came up with our first angle right here, 17 0.6 degrees using the law of cosines. Okay, it's not a terrible equation to use, but there are definitely several steps in there to do it. More steps than with the law of sines for sure. So now if you look at that triangle, we now have an angle side pair, right? We know angle A and we know side A. So that means that now when we move on to solving for angle B and angle C, we have another option because we could use the law of cosines to solve for angle B or angle C, but we can now go to the law of sines because we have an angle side pair to solve for B or C. You know, the law of sines is a little bit easier, so let's do that. Let's switch now to the law of sines and just save ourselves a few steps of work. So let's say I want to solve for B. Okay, so I'm going to use the law of sines now. I'm switching gears and I'm going to solve for B. All right, so sine A is going to be sine of 17.6 degrees over side A. And I'm going to solve for angle B. And side B is 8. Okay, so now you just cross multiply and solve for angle B, right? Still a few steps, but a little bit less complicated than the law of cosines. So now just divide by 5. Okay, so 8 times the sine of 17.6 degrees divided by 5. That's going to give you what the sine of angle B is. It's about 0.4838 when you put that in your calculator. Then take the inverse sine of 0.438, and that's going to give you angle B, right? And angle B is going to be 28.9 degrees. All right, so now we've got two of them, 28.9 degrees. All right, so we've used the law of cosines, then we use the law of sines. For your third angle, now you have even more options, right? Because the third angle, you could, if you wanted to, use the law of cosines. You could also use the law of sines. Or the easiest of the three options we have available to us, right, is that for angle C, we can just say that is the difference between 180 degrees and the two angles we've already figured out. Just subtract those from 180, and that's going to give us angle C, which is 133.5 degrees, right? If I take that angle and I now come up here to my triangle, which is obviously not drawn to scale, 133.5. We mentioned that at the beginning though, it wasn't drawn to scale. Okay, is the largest side opposite the largest angle? Is the smallest side opposite the smallest angle? Does it all look proportional and like it should look? Okay, are we okay? It looks right, right? Longest, largest, looks all right. I think we're good to go. All right, we did it. We used the law of cosines to get us started, but then we used our other tools to help us finish. Okay, so that was a triangle that had all three sides. We didn't know any angles. Let's do one where we are given one angle, an example of side angle side. Okay, so again, here's triangle ABC. And for this one, we're given a side, an angle, and a side. Again, we're not given an angle side pair. So that means we can't use the law of sines to get us started. Okay, so what I want to do is I want to solve for side A. Because if I solve for side A, then I'll have an angle side pair, and then I can switch to the law of sines if I want to. Okay, so I'm going to use this version of the law of cosines and solve for side A. Okay, so I'm just going to plug everything I know into that version of the law of cosines and solve for A. Okay, so I don't know A, but I do know B, it's 10.5. And I do know C, it's 18. So B is 10.5, C is 18, and it's cosine of 46.5 degrees. Okay, so the entire thing on the right now is just using our calculator to help us do some number crunching there, right? So 10.5 squared is 110.25, and 18 squared is 324. Cosine of 46.5 degrees times 18 times 10.5 times 2 gives me 260.198. So a squared is 174.05, and take the square root of that, and you get about 13.2. Just like that. That wasn't too terrible. It was a little bit of number crunching for sure though. And we get 13.2. Now we have all three sides. Okay. Now we have some options, right? We know an angle side pair now. So you could, if you wanted to, continue to solve this triangle using the law of cosines. You could use the law of cosines to solve for angle C or angle B. Or you can now switch to the law of sines to solve for angle C or angle B. Okay, I think the law of sines is a little bit easier. So let's do the law of sines. So I want to solve for angle B next. I'm going to use the law of sines. Okay, so I know I have an angle side pair with A, and I'm solving for B. Okay, so A is going to be 46.5 degrees over side A, which is what I just solved for. And I'm solving for angle B, and side B is 10.5. Okay, cross multiply that times the sine of 46.5 degrees is 13.2 times the sine of B. And then to solve for B, divide by 13.2. Okay, so take the sine of 46.5 degrees, multiply it by 10.5, divide by 13.2, and you get the sine of B is about 0.577. Then use the inverse sine function on your calculator to find that angle B is approximately 35.2 degrees. So angle B is 35.2 degrees. Okay, look at us moving right along. We're almost done. The only thing we need now is angle C. Okay, so for angle C, you have the option of using the law of cosines, using the law of sines, or being really lazy, which is what I'm going to do, and just subtract your other two angles from 180, right? So just saying, oh, angle C, you know, there's 180 degrees in the triangle. So it's going to be 180 minus 46.5 minus 35.2. And what does that leave us for angle C? It leaves us with 98.3 degrees. 98.3. Okay, and then just look at your triangle. Does it look right? Is the largest angle opposite the longest side? Is the shortest side opposite the smallest angle? Does it look like it should, proportionally speaking? Looks good. I think we did that nice. Okay, so there you go. We used the law of cosines to get us started. We used the law of sines in the middle, and then we finished just using our law of a triangle. Okay, so there you go. There is our law of cosines, a handy tool, pretty nifty for when we need it. It's not terrible hard to use, but a little bit more complicated than the law of sines. All right, everybody have a super day. And thank you so much for watching.